Look up at the night sky. Beyond the beautiful starlight and the familiar glow of the moon, there is a silent, invisible rain falling upon our planet. At this very second, subatomic particles are screaming through your body, passing through the roof of your house, and burying themselves deep into the earth. They travel at nearly the speed of light, carrying more energy than any particle ever accelerated by human hands. These are not photons of light. They are pieces of atoms, the shrapnel of cosmic cataclysms. Welcome to video 55, the mystery of cosmic rays high energy particles from deep space. For over a century, these mysterious travelers have baffled the world's greatest minds. We call them rays, but that's actually a bit of a historical mistake. When they were first discovered in 1912 by physicist Victor Hess, he took a radiation detector up in a hot air balloon, thinking that radiation came from the Earth's crust. Instead, he found that as he went higher, the radiation increased. It was coming from above. It was coming from space. We soon realized these weren't rays like X-rays or light. They were physical particles, mostly protons and atomic nuclei moving with terrifying momentum. Where did they come from? This is one of the most enduring detective stories in astrophysics. Cosmic rays are divided into two main categories based on their energy. The lower energy ones, which still pack a punch, are mostly produced by our own sun during solar flares. But the truly mysterious ones, the high-energy cosmic rays, originate from far beyond our solar system. For decades, we suspected that supernova, the explosive deaths of massive stars, were the primary culprits. When a star explodes, it creates a shock wave that expands into the surrounding gas. This shock wave acts like a cosmic pinball machine, bouncing charged particles back and forth, accelerating them to higher and higher speeds until they are flung out into the galaxy. In 2013, the Fermi Space Telescope finally found the smoking gun, detecting a specific signature of light from supernova remnants that proved they were indeed accelerating protons to near light speed. But then, there are the ultra-high energy cosmic rays. These are the elite athletes of the subatomic world. A single one of these particles can have as much kinetic energy as a professional tennis serve or a baseball thrown at. 90 miles per hour, all packed into a single microscopic proton. The most famous of these, detected in 1991, was nicknamed the "Oh my God" particle. It was traveling so close to the speed of light that if it raced a photon across the galaxy, the photon would only win by a few centimeters. Supernova aren't powerful enough to create these. To reach such insane energies, you need something much bigger. Astronomers now believe these particles are forged in the hearts of active galactic nuclei the feeding supermassive black holes we call quasars, or in the violent collisions of galaxies. These are the great particle accelerators of the universe, using magnetic fields millions of miles long to whip matter into a frenzy. So why don't we feel this invisible bombardment? We owe our lives to two invisible shields: the Earth's magnetic field and our atmosphere. Our magnetic field acts like a cosmic deflector shield, bending the paths of incoming charged particles and funneling them toward the north and south poles. When these particles strike the upper atmosphere near the poles, they excite the gas molecules, creating the shimmering, dancing curtains of light we know as the aurora borealis and aurora australis . The particles that make it past the magnetic shield hit our atmosphere like a bowling ball hitting a set of pins. High in the stratosphere, a single primary cosmic ray strikes an air molecule, creating a secondary air shower. This is a cascade of billions of subatomic particles, pions, muons, and electrons that rain down toward the surface. By the time they reach you, they are mostly harmless, but they are a constant reminder of the violent universe outside our bubble. However, cosmic rays aren't just a curiosity for physicists. They have real, tangible effects on our world. They are a major challenge for asterisk space exploration, asterisk. Out in the deep void beyond the protection of Earth's magnetic field, cosmic rays can tear through human DNA like microscopic bullets, increasing the risk of cancer and radiation sickness. For an astronaut traveling to Mars, cosmic rays are perhaps the single greatest threat to their survival. We are currently researching ways to build magnetic shields for spacecraft, or using thick layers of water or lead to protect our future explorers. Cosmic rays also affect our technology right here on the ground. They can cause bit flips in computer chips. A single particle striking a transistor can change a 0 to a 1. This can cause software glitches, system crashes, or even more serious issues in airplanes and satellites. In fact, most modern electronics are designed with error-correcting memory, specifically, to handle the interference of these silent intruders from space. But cosmic rays aren't just problems to be solved. They are tools we can use. We have pioneered a field called muon tomography ***. Muons are heavy versions of electrons created in cosmic ray showers. They can pass through hundreds of feet of solid rock. By placing detectors inside or under large structures, we can X-ray them using cosmic rays. This technique was used to discover a hidden, secret chamber inside the Great Pyramid of Giza and to map the internal plumbing of active volcanoes to predict eruptions. Cosmic rays are literally allowing us to see through stone. Furthermore, cosmic rays might have played a role in the history of life itself. Some scientists suggest that the constant background of cosmic radiation has driven the rate of genetic mutations over billions of years, acting as a slow, steady engine for evolution. Without this subtle pressure from the stars, life on Earth might not have developed the diversity we see today. We might be here because of the stars that died millions of years ago. The study of cosmic rays also connects us to the invisible universe. Because these particles are charged, they are bent by the magnetic fields of our galaxy as they travel. This makes them very hard to trace back to their source. It's like trying to find where a gust of wind came from in a city full of alleyways. To solve this, we are building massive observatories like the Pierre Auger Observatory in Argentina, which uses 1,600 detectors spread over an area the size of Rhode Island to capture the faintest whispers of these high-energy guests. What these particles tell us is that the universe is a place of incredible, raw power. We live in a quiet, stable neighborhood, but we are surrounded by a sea of high-energy chaos. Cosmic rays are the messengers from that chaos. They tell us about the magnetic fields that weave through the galaxy and the extreme physics happening near the event horizons of black holes. They are a bridge between the subatomic world and the galactic world. Every time you blink, a few cosmic ray particles have passed through your eye. Every time you use your phone, a particle from a distant supernova might have influenced its circuitry. We are not isolated from the cosmos. We are constantly being touched by the debris of the most distant and violent events in existence. The mystery of cosmic rays reminds us that space is not empty. It is a medium filled with energy, fields, and matter moving at impossible speeds. As we continue to refine our detectors and launch new missions into the deep dark, we are getting closer to understanding the true origins of these, oh my God, particles. We are learning to read the history of the galaxy, not just through the light we see, but through the particles that strike us. Thank you for joining us for video 55. The universe is a vast, invisible laboratory, and we are just beginning to understand the experiments running all around us. If you enjoyed this journey into the world of high-energy particles, make sure to subscribe and hit the notification bell. We have many more mysteries to explore, from the hidden dimensions of space to the ultimate fate of the first atoms. Until next time, keep your eyes on the stars, stay curious about the invisible rain, and remember, even in the silence, the universe is screaming with energy. Safe travels through the magnificent bombarded cosmos.